Hello! So I thought I'd share with the internet one of my favourite COVID projects, and basically it is a blood-like game, that well-known genre. And really it's not at all a game. It's kind of a very early, let's say, prototype slash game engine, and I've really just stolen a bunch of assets from Blood. But of course I didn't steal them myself, I really stole them from another guy who effectively ripped them and stole them from Blood. So there's a lot of thievery going on. But anyway, I digress. So what it is something that looks vaguely like Blood. Some differences: it has slightly more fancy shadows, which I'll go into a bit more detail later on. And it's not actually it actually uses full rasterization, so it's not using some kind of graphical trickery which we needed back in the DOS days. But unfortunately this means it's a lot more intensive. So for example, if I show the utilization, the way I could achieve it is by using a lot of threads basically. So it's got good utilization, it's using about just over half each thread. It's a fairly powerful computer. It's a HP Z400 that I liberated from the university. Yet more thievery, I guess. And I mean, it's because I'm recording this, it's also wreaking a bit of havoc. You can see then that the game is using effectively about 350% of the processing threads of the processor, and then FFmpeg, which I'm using to record it, is about 19%. So it's using a fair chunk of it. So the fact that I guess ID Software, or John Carmack, and all the other ones involved in that managed to actually get Quake running on DOS is quite impressive. So this does run in DOS, but it's pretty slow. But anyway, so let's go through it a bit. As you can see, I don't know if you can hear the zombie. He sounds pretty lethargic. So let's go into the shadows. So what I'm quite proud of is the fact that they look quite nice in theory for a software renderer, and you can see here that it's quite accurate. So because the light is around here and the gravestone is kind of in front of it, you can see that it's just creating a shadow just on this small kind of face here, which is pretty good, to be honest. I don't have some fancy system. I mean, it's using ray tracing, how I bake it. I might make another video on that if anyone's interested. But it treats kind of this sprite effectively as a solid, so you won't get really accurate kind of shadows projected on the wall for this. So anything solid, it'll create shadows, but anything that is effectively kind of solid will block out the light here. So bits I'm particularly happy with is you can see here the cross. There's another lethargic zombie. If you're interested, I'll post the sound online if you can't hear it. And so this cross, you can see that you've got the actual shadow just projecting from it. I actually brought this light out kind of just parallel to it, just so we would get that light effect. Because I thought, why not? Let's kill the other zombie. Bunk. So some other stuff. This doesn't quite look great. The light I just dumped here. If it was kind of less parallel, it would create a more interesting shadow. But here we go. This one's really nice. If I just go down here, in the fact that because these aren't kind of sprites, they're actually solid objects, the light that I've placed around here projects through them onto the wall and looks really quite nice. But yeah, it's also generally fast. We've kind of reached the end of the level here, so if I kind of jump off the end, that was cool. So let's reset that. There's nothing really much more to add, to be honest, other than the fact that I've tried to copy off the original Blood as much as possible, which I believe was 320 by 200. So I've done similar here, but also because we want it to work on like potentially phones, your phone's gonna get hot if it runs this game, I wanted it to also scale. So what I actually did was, it'll always be at least 200, or at least in the Y, or at least 320 in the X. So it means that if I scale it like this, you can see that this one, even though it's in theory no longer 200, it actually scales it so that you have this virtual buffer that will always think it's 200, and then it will scale it as it actually draws it to the X11 window here. Likewise in the X, it will also always be at least 320. And this has a really nice effect of, if I start to scale it, you can see that the actual UI components kind of work quite well, so they scale with it. So on a phone, it would approximately look like this. And then you can see, as I bring it out, it no longer needs to scale because the actual width of it is already over 320 in terms of the aspect ratio. So it was just kind of a nice side effect of that. Obviously it was a bit of a kludge, but it actually has a really nice effect. One disadvantage though is, in theory, if I scale like this, it doesn't look like the screen's that big, but it is. So it means you've got a massive buffer here, high resolution, and so you can see that the game kind of judders a little bit more because it's using a bit more of the actual, I guess, CPU. But it runs nicely. I'd say the biggest performance hit is probably the fact that I'm recording it right now. I don't know how smooth it's going to turn out, but for me it's quite fluid at the moment. So that's really the game. Yeah, it's quite nice. I thought I'd kind of cover it at this point because it's still, I'd say I've finished up with the engine, and it's kind of ready to turn into an actual game now if I do kind of take it further. It also has collision. The collision's quite nice. The collision isn't threaded. I should do that at some point. The rest of the engine is heavily threaded, which means that porting it to DOS works, but it means you need to get rid of the actual extra threads. So it runs pretty slow. So I didn't really want this to be much of a technical kind of talk, but if I go into the source code a little bit, let's get rid of him. You can see that I've got a bunch of these different platforms. So X11 platform, SGL, SGL2 platform, and then on Windows I've also got .NET platform that really is just WinForms that just connects to it. So it's actually really portable, so it doesn't need to worry about using OpenGL or Vulkan or anything like that, which is good in the fact that OpenGL is a little bit naff to develop with, and I say that by the fact I actually teach it to students. And it is great because it's cross-platform, but it has some of its own issues. So actually getting away from it's really quite liberating. So I don't need to worry about power of two textures. Memory management is greatly simplified because I'm really just dealing with, you know, arrays of pixels. So yeah. So one of the interesting bits is it's written in C++. But I'm not actually using any of the C++ standard runtime. So anything in namespace std, things like string, shared pointers, things like that, I provide all my own. So the reason being is, again, I can port it to DOS. Because as you probably know, the DOS C++ compilers were pretty young. I'd say the furthest along now is probably OpenWhatCom, which was released after, you know, the DOS heyday. People are still working on it. DJGPP, the sort of like G++ port, is just too slow for me to use, so in the end I went with Whatcom, OpenWhatCom, which has a semi-modern runtime standard library, but to be honest it's still not great, mostly because these ones not only do they provide some safety, like unique and weak. I don't worry about shared pointer. I prefer the ability of unique pointer only having one instance, and then weak kind of pointing to it, but you get the observer pattern. I'm kind of rambling, so instead I've kind of opted to kind of create my own. But some of the good things about this is that they actually have additional checking. So when in debug mode, for example, weak, if I show this won't mean much to some of you that don't really care about programming, but here you can see that when I actually dereference something and I actually go into it, I don't just return a pointer of that type, I return a lock of that type, and that lock of that type, you can treat like a pointer, but it creates a lock, thus its name. So it means that if I basically, let's say, clear an array or a vector while I'm iterating through it and while I'm inside one of them, you never get a dangling this, which is really important. It'll literally just abort immediately. Dangling thises and dangling references and things like that I find a nightmare to debug, even with the tools on this platform, let alone DOS. So that's why I decided to kind of have additional checking during debug, at least. In release, it's all kind of raw and it's as fast as possible. So basically this stuff is on my GitHub account. I will it's a little bit out of date. I use kind of an internal CVS repo, but I've mirrored it to GitHub. I'm probably not so vain as to think this source code is a massive trade secret, so I'm happy to share it. Like I said, I'll put the GitHub in the description on the video. It's fairly portable, so we can port it to Linux. OpenBSD is what it's working on currently, and Windows. I haven't tried it on Windows for a while, but yeah, like I said, I had that .NET kind of WinForms almost front end to it, so it should be right. Finally, I noticed when running it, this is more just out of interest, if you have kind of a big chunky HUD, almost like you do in Doom, you know, showing his face, you can actually pretty much save an entire CPU core in the fact that it won't be rasterizing kind of 3D objects into it. I just left it as this because I find it kind of is a bit less claustrophobic without like this massive HUD taking up so much of the screen. But certainly I do appreciate hacks like that do help it work on DOS. So anyway, that's it from me. Hope the video turned out alright, and see you later.